Hello my audience, welcome back to the video session again. I'm very glad to welcome you with this session concerning with probability of mutual inclusive events. So here is the definition. So I'm saying that mutual inclusive events, these are two events sets having common elements in them. What is very peculiar with these mutually inclusive events, these are sets, actually they are event sets, that is having common elements in them. So whenever two events have common elements in them, so they are including one another. And therefore we call them mutually inclusive events. Let's take an example at least to make sure that this is clear for everybody. An example. Let's say you have a set A whose members are 1, 2, 3, and 4. And again, there is another set whose members are 0, 2, 3, and 5. With these two sets, actually you can see there exists common element in these two sets, and the common element is described as a set A intersection B. So the set A intersection B is consisting of members 2 and 3. So this is the indication that these two sets A and B are mutually inclusive events. Members 2 and 3 are found in set A, and also these two members 2 and 3 are found in set B. So actually if you want to conclude that the two events are mutually inclusive, the main factor is that they should have common elements in them. So our interest is to find the probability of these kind of events. Okay, so now suppose you have two sets A and B which are mutually inclusive, and I'm saying this means that the two sets A and B, they have common element in them. So now let's work under assumption. So I can say now, assume A and B are mutually inclusive. If A and B are mutually inclusive, actually these two sets must overlap in the sense that the two sets must contain common elements in them. So actually, I say A and B must overlap. So we can illustrate this one using Venn diagram. So Venn diagram, call this one set A, call this one set B, and this one is going to be set S. Why S? Because S is representing the sample space set which replaces universal set. So now with this Venn diagram, we can extract the fact coming from knowledge of set. The fact we can extract coming from the knowledge of set is that the number of elements of A union B, the number of elements of A union B equals to number of elements of A plus number of elements of B minus number of elements of A intersection B. This formula for your level, my audience, I believe you understand. This one is coming from set theory. Now, this formula, we can convert this one to represent the formula for probability. The formula for probability. So in order to convert this set formula to become the probability formula, what you do, you have to divide by number of sample space each term. So divide this one each term. So we have to divide the number of A union B by number of sample space equals to number of A divided by number of sample space. Then you plus the number of B divided by number of sample space, again minus number of A intersection B divided by number of sample space. So here now is where everything turns to be a probability formula. So this A union B is representing the event combined. A union B is a combined event. So this one will be the probability of this combined event, which is A union B, equals to, this one will mean the probability of event A, and this again will be the probability of event B, minus again this one will be the probability of event A intersection B. So here now we have the formula you can use to do questions concerning the probability of mutually inclusive event. So this formula, we are going to check some couple of examples to see how we can utilize this formula to solve the probability of combined event A union B, or combined event A intersection B, or generally to apply this formula and be comfortable to work with it. Let's check examples on using this formula. Okay. With this example number 1, we are going to see how we can utilize the formula for probability of events which are mutually inclusive. And this example number 1 is about a die which is tossed once. A die which is tossed once. So you are asked to find the probability that either prime numbers or even numbers will occur. Actually, here you have two events. One event is that prime numbers will occur. Another event is that even numbers will occur. So actually, you have got two events combined. And this is a probability of the combined event which are actually mutually inclusive to one another. We'll see why I'm saying they are mutually inclusive. So to solve this question, first you have to understand what is the probability experiment being talked about. So quickly you will see this probability experiment is involving tossing a die. Now, if you toss a die, the sample space set are supposed to be numbers from 1 up to 6. Numbers from 1 up to 6. And the number of sample space, again, they are 6. So next is to let what will be the event. Here the event is a combination of prime numbers, either prime numbers or even numbers. So we have to break these two events and let a letter A to represent this first outcome. this first outcome. So let A be even that prime numbers will occur, and at the same time let B represent even numbers will occur. So what does the question want? The question wants the chance that the number that will show up will be either prime or will be even. That means the numbers will be A or B. The numbers will be A or B. So the question is asking you to find the probability of A or B equals to what? This is what the question wants, to find the probability that numbers will be prime or numbers will be even, according to the suggestion, according to the assumption of what letter A and B represent. So this is actually meaning, this implies the probability of A or B using the set symbols, or represent union. So this becomes the probability of A union B. Please, again and again, recall set symbols, or implies as symbolized by union according to set knowledge. Now, so basically the question wants you to find the probability of A union B. So how do you find probability of A union B? So you have to find the probability of A union B from the formula that probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B. Now to find this value, first you have to identify the set A, set B, and set A intersection B. Set A, set B, and set A intersection B. Now what will be the set A? The set A, according to the suggestion, is the event set that prime numbers will occur from available numbers 1 up to 6. So here you have to pick all prime numbers from available 6. So prime numbers will be number 2, number 3, and number 5, where the number of A is now equals to 3. Again, you have to suggest set B. According to the suggestion here, set B is even numbers to occur from sample space set. So even numbers will be 2, 4, 6, where the number of elements in this set, number of elements, if you count, they are 3. And A intersection B now. So A intersection B is all members which appear both from set A and from set B. Now you can check from set A and set B. Members which are common. Members which are common, you can check here. They are only number 2. So the number of A intersection B is equal to 1. Number of A intersection B is equal to 1. So from here now we can find the probability that A or B will occur by finding the value of probability of A, probability of B, and the probability of A intersection B. Let's continue doing this question. So now probability of A union B, which is supposed to be equals to probability of A plus probability of B minus probability of A intersection B. So here now you can break this probability of A should be the number of A divided by number of sample space. Probability of B again should be the number of B divided by number of sample space, and this again should be number of, you have to take this set here, so the number of A intersection B divided by the number of sample space. So you plug the informations which are available. Plug the information. Let's come back to informations we extracted. So you have the number of A to be 3, number of B 3 again, but the number of A intersection B is 1. And the number of sample space, because this experiment is involving dye, we've seen that the number of sample space is 6. So you plug the information here, should be 3 out of 6 plus this again 3 out of 6, number of B 3 minus the number of A intersection B is 1 out of 6. So you solve this math and you will have 3 plus 3 minus 1, so you have 5 out of 6. Now the probability of A or B is supposed to be 5 out of 6. This means that the chance that prime numbers or even numbers will occur after one toss of a die is 5 out of 6. Let's check example number 2. Example number 2 is this one. Now suppose S is the probability set. A and B are two even sets such that this S is a member of 0, 1, 2, 3 up to 10, and A is a member of numbers 1, 3, is a set of numbers 1, 3, 5 and 10, and B the set of numbers 2, 3 and 5. Here this language probability set, you have to know to worry about this one. Probability set is another word for sample space set, so it is denoted by S. Now with these two information you are asked to find the probability of A union B, the probability of this event A union B to occur. So actually to solve this question, because everything has been symbolized now, so you have to make a counting that the members inside A, number of elements in set A, there are 1, 2, 3, 5, 4. So we have got 4. And number of elements inside set B, there are 3 members. 1, 2, 3 members. And the number of elements in the sample space set, how many members? So 1 up to 10, 0 up to 10. So these are 11 members. If you count, it's supposed to be 11 members. So now you are asked the probability of A union B equals to 1. But again, another important thing is the number of A intersection B. How many members appear from set A and set B? In order to answer this one, first, what is set A intersection B? What is this set? So this set is going to have common element from set A and set B. So set A and set B, these two sets, the common element is number 3, 3, number 5, 5. That's it. So you have 3 and number 5. So the number of elements inside this set, there are only 2 elements. 1, 2. Only 2 elements. So from here now, you can define this one. So we say from this formula, probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. If you break down these probabilities into ratios is supposed to be the number of A per number of S, and this one will be number of B per number of S minus number of A intersection B per number of S. So substitute the values, simplify, that's it. Now the number of A is equal to 4. So check this one. So get 4 divided by 11 plus the number of B is 3. So there number of B is 3. So you have to put 3 out of 11. Then minus the number of A intersection B, which is calculated to be 2. So it's supposed to be 2 out of 11 again. So if you simplify this fraction, you will get 5 out of 11. So this is now the probability of A union B. Wow, we are continuing with solving example number 3, which is this one. This example said that in a certain school, 50 students eat meat, 60 eat fish, and 25 eat both meat and fish. If 5 students eat neither of the food, and it happened that a student selected at random, you are asked to find the probability that a student eat meat or fish, and part B, probability that a student eat meat only, and part C, the probability that a student who is selected at random eat neither type of food. So this question is about probability, but is incorporating the concept of set. In order to solve this problem, first of all, you have to represent the information given in a Venn diagram, because a Venn diagram is providing a relationship between sets. So we have to do that. Let's check how we draw the Venn diagram and then solve this question very easy. Okay. So let M to represent set of students eating meat, and F to represent set of students eating fish. So from here now you can introduce a Venn diagram of two sets M and F. So that Venn diagram supposed to be this. So you have two circles. Call this set, the first one, set M, and call this set F. So this rectangle is a sample space set. Actually, because we are dealing with probability, so don't use the symbol for universal set, use the symbol for sample space set. Now, how many members are found inside set M? How many members eat meat? So the question said earlier that 50 students in the school eat meat, while 60 eat fish, and we don't know actually how many members in this school. By the way, we don't know, because it has not been said. But also it has been said that 25 students eat both meat and fish. So this portion is common, so you have to plug 25 of the students eat both meat and fish. And the question also went on to say 5 of the students eat neither of the two types of food. So you have to place 5 students outside of both circles but inside the rectangle, inside the universal set. So here now you have to check now with this circle which is supposed to contain 50 students, but already inside this circle there exists 25 students. So the remaining one will be 50 minus 25, and you'll get 25 students in this portion. And again, this portion is supposed to be a total of 60. Take away this 25 and you remain with 35 students. So now this is the representation of information given using a Venn diagram, and now we are in a good position to answer the question based on probability. And so part A, if one student is selected at random, you're asked to find the probability that a student will eat meat or fish. So actually this represents the probability that a student eat meat or fish, which actually means the probability that M union F. Why union? Because of O. Always O is symbolized as union. So to find this, you have to use formula for mutual inclusive event. So you say from probability of A union B, which becomes probability of A plus probability of B minus probability of A intersection B. With this information, in order to find, so you have to say that you have to have the number of A per number of sample space. You have to have number of B per number of sample space minus number of A intersection B per number of sample space. So we can quickly solve this one by observing the number of members inside a particular element. Now, number of element inside A, so set A now is going to be represented by M. Set A is going to be represented by M. So for this time, set A will be equivalent of set M, and this set B will be equivalent of set F. Now this will be as a set A and this will be as set B. So members inside A is resembling members inside M. So how many members inside M? They have to be 50. So the number of A is 50 per number of sample space. So number of sample space we don't know here. So you can see we don't know how many members, but members inside set S is supposed to be all members inside this rectangle. So inside rectangle all members are 25, 25 again, 35 and 5. So all these 4 values will make a total of numbers which is supposed to represent the number of sample space set. So 25 plus 25 is 50, and 5 and 35 is 40. 50 and 40 you get 90 degrees. 90, it's not 90 degrees, I can say it's 90. Now, so 50 per 90. And again, plus number of element inside B. B is now for F. So B is for F. B is for F. So number of members inside B is 60. So it will be 60 divided by 90. 60 divided by 90. Then subtract number of members inside A intersection B. A intersection B is this set, which is 25. So it will be 25 per 90 again. Solving this fraction, it will be 50 plus 60, which is 110. Then subtract with 25, and from there you'll have From there you'll have 10 minus 25 divided by 90. So simplifying this fraction, and you'll get 17 over 18. So this is now the probability of A union B, which represent the probability that a student selected at random will either eat meat or fish. So this is part A, and now we are free to move with part B of the question. Now part B of the question is to find the probability of M only. The probability that a student selected at random will eat meat only. So if you remember the diagram, we said here, if it is set M, this is set F. So we said here is 25, here again 25, and here 35, and this one is 5. This whole set is having 90 students. So now the probability of M only will be equals to number of M only divided by number of sample space only. Number of sample, sorry, let me correct this one. Let me correct, other students might confuse. So probability of M only will be equal to number of student taking meat only divided by number of sample space. So now members which are found in M only are here. So we have got 25 students. So it will be 25 students out of all students available in the school are supposed to be 90. So this will be 90. Simplifying this math, you will have 5 out of 18. 5 out of 18. So this is the probability of students eating, probability that a student selected at random will eat meat only. So that is a solution for part B. We solve part C. Solving part C asked the probability that a student selected at random eat neither of two types of food identified. So this means that all students would not eat meat or fish. That means you have to take all members who are outside set M and outside set F. So this means the probability, so you have the number of students who eat meat or fish, but not. So we have to oppose not eating meat or fish. So those students are 5, and number of sample space equals to 90 degrees. So the probability of this event, neither meat or fish. So this dash represents neither. So neither meat or fish are supposed to be number of neither meat or fish divided by number of all students available in the school. So this will be 5 out of 90. And this, if you simplify, it will be 1 out of 18. 1 out of 18. This now will be the probability of neither M nor fish. Thank you for this following up on this example number 3, and this session is closed in that manner. this session was about probability of mutual inclusive event. So I'm ending up with the 3 examples, and I believe they'll be of more help